Hi. This is 10:30. Well, thank you everybody for coming along. I'm Brian. I'm supposed to be helping organize this conference, but I was part of the company that was organizing the conference. I didn't do much. Dave and Taylor did a ton. I'm really grateful. So I wanted to talk about performance and in JavaScript. And this talk is kind of like a two-part thing. So the first part, I'm just going to rant on my opinions about performance. It's going to be just like slides and comments and whatnot. The second part is going to be my ideas for optimization on performance and stuff. So I hate performance, but I'll show you how I think we should optimize performance. So if you're bored with talking on the first part, hang tight. I'll show you a bunch of code on the second part. And just, I guess I'll take questions at the end, but not trying to be a troll or be mean or anything. I just have my opinions and thought I'd share them. All right. So you guys, we've got a problem. We have this like perverse obsession with speed right now. When was the last time you saw a micro benchmark? Was it in the last 24 hours? Raise your hand if you've seen it. All right. It's basically every time I wake up and I look on blogs, Hacker News, whatever, it's just, this is faster than that, and that's faster than that, and there's, we should use closures, not new, or new then closures, or no for loops, and this and that. I'm not saying that these things aren't good, but we've also got like, full-on books and people like spending a lot of their time learning JavaScript execution, like micro optimizations and how the stack frames work and all sorts of crazy stuff, way low level. But the typical JavaScript developer is just making apps. And we have a lot of other things to learn besides this stuff, you guys. And so I have this, there's a brief history of why I think we might be where we're at right now, hailing performance as the #1 highest thing that we are into. So back in the day, there was these, hard statistics saying like, oh, people will leave your site if it doesn't, render in like under 3 seconds or whatever. And so that launched all these like, performance stuff. And we've got V8 coming along with Chrome and these browser wars. And here's Squirrelfish coming around the corner. Now there's Trace Monkey, and it's like this anthropomorphic like, track race thing going on. But they're all basically saying like, oh, JavaScript execution speed is faster here. And so you watch, we sat here and watched as crowds of people went to different browsers, and we're like, oh yeah, that's where the jam is, okay. And then you got this sad state where the native developers were like, oh, you guys are so slow and native is so fast, and HTML5 will never work, and you guys need to stop trying to make apps, and slow, JavaScript's too slow. You got Facebook leaving, right, and LinkedIn saying, oh, we got to go native now. And this isn't just the front end. You got Ryan Dahl writing his manifesto, and people saying like, oh, yeah, Node, it's so fast. We got to go do Node because it's fast. It never blocks. And you've got these, these charts and stuff that's saying, oh, well, all these other stuff, they block, and we don't block. And then LinkedIn is like, we lost all our servers, and we have 1 developer now, and it's 1 billion times faster. This actually went back and got corrected, right? But it's fine. But go speed. So people on the server side, like, we've got a lot of performance people in the Node community. You got performance people, or at least people like shivering in the corner, like, oh, I got to go faster in the front end. And it's leading. I mean, like, obviously, performance is great. We all want our apps to go fast. There's some bad parts to it, I'd say. So for one, we have this perf paranoia thing going on where you have people saying like, oh, can I use semicolons? Is that fast enough? People like, oh, big switch statements, is that good? I can do that, right? And of course it doesn't matter. Here's somebody trying to inline JavaScript for the JIT, like, I'll help the JIT along, it'll be faster, right? I mean, whatever. Here's some wildly inaccurate search results I did. So I didn't know how to search for for loops, so I did for I, which is like 8 million, and for j, which is like 7.5 million. There's a bunch of other letters, and there's so many reasons why this doesn't work. And then this is like half the results for a for each. And I was like, okay, you've got like 15.5 million for like a for loop and like 4 million for each. I tried to search map, but it just came up with a bunch of nonsense. So, but it just kind of gets across the feeling that I get whenever I go see, like, I'm seeing people write code and I see for loops all over the place. And I'm like, why are we still doing this? This is so weird. And if I go search Google for more inaccurate search results to back up my claims, we have performance in JavaScript is 134 million. Fast JavaScript is 177 million. Maintainable JavaScript is only like 500,000. It's hundreds of millions compared to 500,000. As we know, speed and maintainability are often at odds. Not always. I think Dalton's going to give a great talk later on some stuff that might prove this wrong. But I think a lot of people just, when they write their optimized code, it takes a lot longer. It's a lot more complex. Here we have our just map that's exposed to, on the left side is the for loop that's, if you look at any benchmark, it'll just stomp map into the ground. You should never use map, blah, blah, blah. But if you look at this, we've got our closure bug, out in the open. We've got all these loose variables. It's really complex and hard to look at. And map is really concise, even though it's dog slow. Here's a quote from Stoyan's blog. Am I saying that right? Is it Stoyan? Anyway, he was saying, namespaces are fantastic, but dot property lookups are slow, so we can't have namespaces. And he goes into, of course, this is extreme JavaScript optimization. I don't think he's suggesting that you do this in your app, but sure enough, somebody I'm working with, a year back is like, oh, I can't use dot notation. That's too slow. And I was like, oh my gosh. So like it's not helping. It's these micro optimizations. It's like it's cool to know, but we shouldn't be all experts on this. We should just kind of like let the frameworks and libraries kind of work on this. So we have global variable caching. On the left side we've got our extra variables and like you can get out of sync and it's extra code, and we're basically like, oh yeah, the JavaScript execution context has to like leave the function and go look up the variables, and on the other side it's just there. Honestly, I watched some great talks on what the JIT can do, and it's like it probably does this stuff for you. I'm no expert, but people are doing this today in our community. And here's just an example of how performance can be at odds. It's an unrolled loop here on the left, and then just a normal for each. If you don't know what an unrolled loop is I guess 8 might be the magic number for unrolling a loop, but it's basically turning a loop into a sequential process. So that's one thing. You've got the perf paranoia, people worried about every little decision growing up into a bigger and bigger and bigger decision of, oh no, like if I didn't write all my loops in for loops, it's going to be a slow app and I'll never know how fast it could have been. And it's not a good situation for maintainability. So there's another darker side of this is people tend to come up with new ideas often, and they'll say like, oh, check out this new meta-programming technique I came up with, or aspect-oriented programming is really neat, or DCI, or whatever it is. New things come out, and they're met with like an angry mob of performance people that are like, that'll never work, we cannot do this. It has to look and read like C, always. New ideas are not welcome. And so this is for JS, and I want you guys to be aware that like, every time you go and leave a comment with a benchmark saying this will never work, you're basically just smothering it and telling all the new people and all the new ideas, like, we shouldn't try that, you can't try that, we have to stop. So here's just an example. And this one's with, like currying. Someone was like, oh, we'll never use this, even though DOM might be the bottleneck. If you do hit a bottleneck, it's going to be currying, and I'll never use it in production. And you guys remember when the promises and callbacks things came out? They're like, oh, callbacks and promises are slow. Thank goodness promises won, though. That was awesome. And then Pete Hodgson, he's talking today. He had a great post on why you should program, or how you can program without this, and basically doing all these cool little object-oriented things through closures, and you have truly private variables and whatnot. But if you looked at the comments, it was just ripping them to shreds. And it was so sad, because of course you can do this in your JavaScript. It's not going to be that slow, unless you're really like looping through like 10,000 things and you need to have the prototype to look up the method really quickly. But yeah, it's just new ideas just being shot down and thrown away. I don't know if that idea is necessarily new, but it's fun. So what does make our stuff fast, right? If you just go check out your page speed scores, it's not talking about, oh, you know what, your raw JavaScript execution speed is your bottleneck, you guys. You should really optimize your loops and such. I mean, it's mainly like, oh yeah, compress your images, you know, gzip, try to reduce your server. And you know, in response to somebody asking Paul Irish, you know, about like selector speed, he would say this, hey, you're not allowed to care about performance unless you concatenate all your JavaScript, have it at the bottom, minify your CSS and JS, gzip all your assets, losslessly compress your images, so on, etc. Yeah, and you're just not allowed to care about it until you do all that stuff. And I have a suspicion that a lot of people aren't doing this stuff. They're just like scared. They're scared to write higher level nice code because they're like, oh, I want it to be fast, and I don't know what makes it fast because I just see blogs all day. So I did a bunch of tests at my house, and I was going to share them with you, but then I got scared to share them with you, so I'm not going to. Basically because it's, you know, there's no real way to, you know, benchmark real life applications. But this is what I found in my tests, and I encourage you to go do your own tests. So basically, in every single web app I've made in JavaScript over the last like 5 years, I've done an AJAX call, I've done some JavaScript, and then I've done some templating or put it on the screen. That's all I do every day, day in, day out. And that JavaScript stuff that's coming from the server is usually paginated, usually already in a decent enough format. I mean, I might split, sort, do all sorts of crazy stuff to it, but even then, it amounted to like nothing. And so optimizing my app, if you like flip it around, your app code is that 2%. That's all you're working with. And if you're just like ripping it apart, trying to be fast, you know, of course everybody will tell you, find your bottleneck, optimize it. But I think there's a lot of people who don't have time or the mind to go do that, and they're just scared, and they're just writing imperative code for no reason. So you could look at this really easily in the web inspector, and you'll see this pie chart, and that yellow part or orange part, I can't tell. I'm not colorblind, but I just can't tell what color that is. Is that yellow or orange? Anyway, so the whole thing is, that's just JavaScript called the AJAX call, and then it returned, or JavaScript did this DOM work, and then it returned. It's not JavaScript, so you might be thinking it's all JavaScript, but no, it's mainly all this other stuff. It just gets lumped into JavaScript because that's the caller. And you can look at the self time and try to figure it out, but even then it's really hard to figure that out. So yeah, we have people who know this stuff, and they're working on this stuff every single day, and they're making libraries and trying to help us get faster, and they're experts. And I think that, you know, we should use their stuff and just let them be the experts. We don't all have to be the experts on micro optimizations and JavaScript execution and all this stuff. Another thing is JavaScript is a single-threaded interpreted language. So we're not going to be the fastest. You know, like we're kind of starting with a limp here. So then you get people like TJ Holloway-Chuck like writing like, oh, I'm frustrated, I'm going to go to Go because Go's so much faster. And it's like, well, if you put performance as the top thing in your community, there's going to be more performant things out there because they're compiled and they're distributed and they're threaded and all sorts of stuff, right? And this is, I like this quote though, because he says, I'm frustrated by Node's direction, which favors performance over usability and robustness. And I kind of agree. I feel like everybody's just very performance aware, maybe because of that history stuff, but I think there's a lot of other things that we could be aware of. So this is going into like part 2 where you might get some more code, not just my, my opinion. So meanwhile, back at our lovely ranch, it's, you know, we're not really placing that much importance on correctness. And, you know, I was trying to think about what is the strong point. If JavaScript is a single-threaded interpreted language, like what are the things that would make somebody say, I use JavaScript, and JavaScript is the reason I'm like, you know, there's just so many reasons to use this language. And I thought, hey, it runs everywhere, right? It runs for node bots, and it runs for, you know, like on the server and the client and phones all over the place. But you go do that, and it doesn't look like the same language everywhere. Here's some node code on how to do a HTTP call. Here's a browser, node, browser, node, browser. It's crazy. So different. And this is low level on purpose, so we can build abstractions on top of it. And luckily, TJ Holloway-Chuck, before he left, wrote Super Agent. And now this is the same for both. And the good part about this is it's High level, it's declarative. It works in many environments, and you don't have to worry about like doing all this close to the metal stuff. It just works. So I think we need to spend more time on doing stuff like this rather than becoming performance experts. Of course, you have to be a performance expert to be doing this lower level stuff, so it kind of is catch-22. But the idea is that we want to write bigger, more maintainable stuff, so application developers, once they learn how to write a good app, they can go learn other things like security and how to progress the web and not how JavaScript actually works under the hood. So let's get into declarative coding for a minute, because I'm really into that. So if you don't know what declarative coding is, this is SQL. It's, you just write your query in one expression. You say what you want, not how you want it, or how to get it, or how to do it. So this is just, you can let the SQL folks optimize all day long, and your expression doesn't need to change. If your application code was like this, you would not need to change your application to optimize it, right? It would just be optimized under the hood. So if we look at filter as a JavaScript version up at top, that can be optimized all day long. But down below, that's not very easy to optimize. There's no level of abstraction, it's not very declarative, and so on, etc. So this is how I write apps. I get really overboard with, with declarative functional stuff. This is from our workshop. But the point is that there's so much wiggle room for changing the implementation of it under the hood. And once you get into that stuff, it feels really good because it'll run in any environment, and you can implement it differently, and you can optimize it. And I think that's a better way to write apps, and maybe we should be working more towards that. Maybe not this functional stuff, but declarative. So as far as part 2 goes, I'd want to write an app like that, but it's not fast enough. So what if we could have our cake and eat it too? So let's check this out. So optimization number 1 for high-level declarative things. This is called loop fusion. I've talked about this before, and people are probably familiar with this. So up at the top, it says, hey, the left side where we're mapping the function f, we're iterating over a whole entire list and running f on it, and then we're iterating over it again and running g on it. That's the same as just iterating over it once and running both at the same time. And we can actually, that top is valid code that I would use, and I would just instantly recognize and replace with the right side as it's faster. And down at the bottom is the chain syntax. Might be more familiar. So to make this more concrete, we could run through a list and capitalize everything, and then grab the first letter, or the second time is much faster. It only iterates once and capitalizes and grabs the first letter. And here's the same thing in chain syntax. I'm showing you that for a reason, because I think we should be doing that. And I'm not saying there are plenty of people doing that. But I think we need to do more of that. So guess what? It works for functors and monads too, you guys. A list, you don't need to know what a functor and a monad is, but you do need to know that if you're writing stuff in a functional style, almost everything you do is in functors and monads. So a list is one. It's just a container type, and it is a functor and a monad. So everything you can do for a list, you can typically do for these other things. So if I was going to map over my monad, I could actually fuse that mapping. So here's another cool performance optimization from the declarative high-level programming world, shortcut fusion. So here we are. It basically says if we have a fold or a reduce, and we're doing that right after building a list, we're building with this G function, we could just shortcut that and call the G function. Let's take a look at that. Don't worry about the type signatures. I just wanted to be a jerk. This is a way to do it in JavaScript. You've got a build function. And build, all it does is inject the concatenation operator. I just use this push helper here and empty list. And that will just basically inject that into the reduce for map. But if we do it that way, you could basically say, if we're going to first map over an entire list and square it, and then we're going to basically fold that list down to a sum, or reduce that list down to a sum, that commented outline is equivalent, and it can do the exact same thing in one iteration. So it's just like loop fusion, but here we're fusing folds. So that's pretty neat. And here's the exact same thing in kind of like a low-dash syntax down at the bottom. So you could replace that chain with one that does the reduce. This way you don't have to map over everything and then sum it. You could do it in one go. That kind of, you need good producers and good consumers, the things that build up lists and the things that consume lists. And here's just a short list, but it's basically everything that you would expect, right? Like any, all, sort by, map, filter, concat, like these are things that you do all the time. It's not like, oh, these are the only things you can do. But check it out. It works for functors and monads too. It doesn't just work for lists. We can actually shortcut fuse our monads and functors, and that's amazing if you're expressing your entire app in it. They call it deforestation. If you're basically every step of the way using these objects, it can get rid of all the intermediate objects and do things a lot more efficiently. So let's talk about something you probably do know. Here's memoization. Raise your hand if you know what memoization is. Okay, great, awesome. But the idea is that if you have a function that takes some value and runs it, the second time it goes, it'll actually remember the output for that input, and the second time it runs, it doesn't actually run it, it just returns the output, it's just cached. And you can do that for any pure function. So here's it in action. If I call add 20 with 10, then I call it again, it doesn't run the second time, it just remembered it because it was 10. And then the third time, it does run because it's a different number, but if I ran it again with 11, it would return me without, it wouldn't run again. So you can just wrap that around any function, right? This memoize thing, and then it'll just remember it. But what people don't realize, or it trips up a lot of people here, is that if you're memoizing pure computations, here's a future that goes and gets posts. Futures are just like promises, except you have to tell them to run. They won't just run on their own, so they end up being pure. But what happens here is we make a new future that will go get us posts for whatever ID, like ID number 5. And the second time we call get posts with 5, people might be like, oh no, you just cached your posts, that doesn't work. But no, we're just returning that same future that will go get our posts. So we don't have to make new objects every time, it just returns the thing that will go get us our posts. So you can totally do that for things that seem like they're not going to be impure, but they are actually pure. So here we call get posts with 2, it returns us a future. I call it again, it returns us the exact same future. And then 3, it returns us a new future that will go get posts. So these things aren't getting posts, they're not promises, they're things that will go get posts. So it's just a post or a future basically with a value inside of it that hasn't happened yet. And we could also do this with jQuery. So we have this 2IO helper from Monet.js. Chris Myers made it. His slogan was, when you actually absolutely have to use JavaScript, which depressed me. But the idea is that you have this thing that will go get all the trolls, right? Everything with class troll. And it doesn't actually do it. It just returns us an IO of something that will do it. And then we run IO, and we run IO. You might see it called unsafe perform IO. And it'll get different things each time. But the fact that it was memoized is it's just saying it's going to return you that same IO. It doesn't have to go construct a whole new IO every time. So that's pretty neat. So needless to say, that works for functors and monads. It's pure computations that can all be memoized. Basically, your whole app can be memoized. Here's a parallel code. So here on the left, we're showing the associativity rule. If we run, it doesn't matter how we group our inner calls. We can call f with the result of x and y, or f with the other result. The inner ones run first, and that's fine. Here's an example. Here's add. And you guys might say, oh, you can add 2 and 3 and add that result to 5, or vice versa. It's also commutative, which is pretty neat. But that means we could write it, and it doesn't matter how we group it, right? We can just write as many things inside of this as we want, give it a list or a variadic add, basically. And this can be parallelized. And you might be thinking, no, it can't. This is JavaScript. We can't do parallelization. Of course we can. We've got River Trail coming out. We've got web workers. We can spawn child processes. There's ways to do parallel code. We just hinder ourselves and don't try because we're all like, oh no, imperative mutability, blah, blah, blah. And we don't have any really nice declarative syntax that allows us the freedom to go try to implement this stuff, because everybody's JavaScript is like for loops and things that's like, well, I can't make it parallel because it's too low level. So here's another way to do parallelism. It's a applicative functor syntax, but basically what we're saying is, and you don't need to know what this stuff is, I'm just showing you stuff that is really high level and does things. So one example is down at the bottom, if we want to do 3 long running calculations and then collect the results, basically what this is going to do is return futures. In the applicative instance for futures, we'll wait till each one is done and pass the results to collect results, right? But the idea is that it can be run in parallel, and there isn't any effort going into that because nobody's really doing it. And it doesn't have to just be for futures. It could just be for normal things like validations. Just normal calculations. It's just the way you express this is totally declarative. There's no step-by-step instructions. There's no sequence, no evaluation steps. Like first run this line, then run this line. We could just consume it and do whatever we want under the hood. So it works for functors and monads too, you guys. I just say functors and monads, basically saying like, you know, like applicative functors are functors. I don't know if this isn't a functor syntax, it's applicative. But the idea is that the things you're expressing your entire app in can take advantage of this stuff, particularly monoids in the case of the parallel associativity stuff. So I want to talk about some cool ideas that I have, because you know, I've got this time. So here's the example from Lodash-docs on chain, and you know, we're going to sort them by age, then map this string over it, and then grab the first value, and then extract the value from it. This is actually a comonad, but the idea is that if each step of the way it didn't actually run, it just built up a computation to run when we call that dot value. Basically, it lazily builds up a computation for you. Then we could say, oh, hey, instead of running immediately, we noticed that you called first right after map. So why did we map the entire list when we could have just called first and, you know, we could actually do some fusion there, or at least rearrange it a bit. And this is, you know, these are these high-level declarative APIs that we could be coding with all the time, give us the flexibility and freedom to do that. It turns out there's already a library that does this. I don't know if there's many people using it. But I think we could combine efforts and try to do some more lazy coding in Lodash, which is my favorite library for doing this kind of stuff. So here, you know, you can see a map, unique take, but nothing happens till that bottom line. See that unique rands from 1 to 1,000? We call that each, and it basically extracts the value from that computation. It basically says, like, run this now. So everything else up until it doesn't do anything but build up a computation. It's like the command pattern. It's basically like promises. You're saying do this, do this, do this, and it's not going to do anything until it actually gets resolved or until we call each. Or, you know, and you might be familiar with this style through Bacon.js or React or Reactive.js or RxJS. I mean, a lot of these different you know, FRP libraries and stuff do this, but we could just do this for everyday code. Just build up your computation, and we can compile as we code. We can kind of make these optimizations. That's a pretty neat idea. So that works for functors and monads too, you guys. Can you believe it? It doesn't just work with lists. We could work with all sorts of different data structures and put computations inside them. And if you're expressing your app in a functional way, you'll probably have kind of this like monad stack. And as you put computations inside it, it's taking into account asynchronous programming and things like that. So null checks and whatnot. And this is really powerful because you can do optimizations throughout. There's other ways you can do this stuff. Here's Puffin Fresh wrote this like rephrase. He basically ported Haskell rewrite rules over. So down there is the loop fusion we were talking about earlier. If you map, then map. This says consume the app and like just every time you match that, replace it with this. That's a way to go about it. I'm not big on the pre-processing stuff, but you know, something we can do today. Basically another way of going about this instead of runtime compilation. And we could also take it a step further by inlining all our functions and then running the rewrite rules, things like that. So this is just a handful of ideas and optimizations from very high-level declarative code that if we're writing high-level declarative code, we could be sharing our JavaScript code in different environments. We could be optimizing under the hood. We could be putting our effort towards this instead of everybody trying to learn where this, the execution context goes, and then what everything is doing under the hood. We could be working at a very high level for application developers. Yeah, that's really all I've got. So thank you. Does anybody have questions or just want to yell at me about performance? What's up? Oh, sure. Yeah, that is the point. You basically there's techniques for compiling as you code or whatever, and it's a lot like a promise. You just store functions in there, and perhaps as you're storing them, you could say, "Oh, I just had a map and a build. I can do our shortcut fusion," and then you just keep doing that. And I think nothing happens until you kind of run it. It's like you're setting up dominoes. So and then you push it down, and as you're setting them up, you can just have this little mechanism to fix it up. So. Did I repeat the question? I probably didn't repeat the question, did I? It was about lazy.js, and you missed the point of, or I didn't express the point well of, it could compile as it goes. What's up?
Brian. Yeah.
Well, I think that anything is production ready if it runs. But that's my opinion. I'm crazy. But I think that there's probably a lot of problems with it, right? You shouldn't just go out and start using stuff. But like Christian said right before this, use it, find bugs. Let's try to write the stuff we want to write. Because if you're writing what you want to write, they'll optimize around us. They'll optimize the code. They'll have way more wiggle room. And somebody was talking about this the other day, how the JavaScript actual engines will, optimize to what you're doing, and it's why not do that? Gia, what's up, man?
So you mentioned that you could change.
I'll try. I mean, yeah, I'll totally help you, man. This is a Lodash maintainer back here. So.
That would be really awesome. There's like a 2-year-old bug issue that says, hey, we need this.
Oh, excellent. Yeah, I'm very happy to work on that. I'm the last person that should be working on performance. I should have admitted that first. But I'd be happy to try to work on stuff. The idea is that I think what I really wanted to express is people, they learn enough in JavaScript and they get to a point where they're like, well, what do I learn now? And then they see blogs and speakers and all this stuff every day about performance, and you need to know how everything works down to the metal. And then they don't learn oh, well, why don't we write higher level things or work on that stuff? It's all very, very, very low level, and it's I think we should be, as application developers, not as library developers, but as application developers working on that. So, but yeah, I'll totally try to help. Let's talk about that later. Any other questions? What's up? Oh, I have a workshop tomorrow if you want to come. But yeah, it's a space burrito. Any other questions? All right, thank you guys so much.